Great technologies. This is great technologies. Trust me. Focus, collaborate, and start practicing. Super, guys. Yeah, Harun, you can take over. Yeah, you're on mute. Keep doing great work, everyone.
Thank you,
Akshata,
Srini.
you feel good? You feel good learning, Akshata?
Yeah, I feel good now.
Super,
Thank you for
super.
asking.
Kishore, I know you're busy in Hyderabad, but you need to make sure you crack this stack in this batch.
Yes, Srini, absolutely. Srini, I'm practicing also.
Super.
Yeah,
We have two Prasannas, Lakshmi Prasanna and Prasanna Gattam Nene. Both are coming to Dallas. Of course, Prasanna is already here. Okay. So super. Purnima is also in Dallas. Nag is here. Sahil, you need to come here. Sahil has a lot of relatives here, cousins, etc.
Yeah, definitely. Sure.
Yeah, I don't know. This class has more Dallas and Frisco folks. So when I started
Venkat
my
has
class,
joined from
I have more
Hyderabad, I
from
think.
Bay Area.
But
Venkat from Hyderabad also joined. Great, guys. Please continue. We'll do even advanced topics. So Wednesday, there will be one sessions. There will be break next week, a long weekend. You enjoy? Then we'll come up with more interesting topics, guys. Yeah. Great, guys. Enjoy.
yeah, thank you, Srini. Yeah, team, welcome. Welcome for the another session on Apache Spark Databricks. So yesterday we discussed quite a few topics. We discussed about DAG. We discussed about the caching the data frame. We discussed about the lazy evaluation, how the transformations, various transformations, actions, how they are stored as instructions and executed based on the actions whenever you call an action on that. We also discussed about the shuffle, why and when the shuffle happens, how it impacts the performance. Yeah. So we also discussed about repartitioning, how shuffling impacts the repartitioning, impacts the shuffling, and then how the data is shuffled across network in the different nodes or in the machines, basically for further processing, right? And we also talked about why shuffling is required, basically in joins, and how to avoid shuffling, and what are the best what you call optimization techniques. So best practices for optimization. So we briefly touched upon that, right? So we talked about cache and persist, and different modes of how we persist, right? Can anybody just review or revise talk about what are the different modes of caching that we did yesterday?
We don't recall the name.
I can.
Yeah, I'm just looking at volunteers. Yeah.
Memory, memory and disk, memory and disk serialization.
Right.
Disk only, memory disk serialized. Yeah.
Okay. Yeah, nice. Yes. So we have a combination of memory and disk to store the interim results of a data frame. Basically, so you can store everything in memory or everything in disk, or combination of memory and disk, and then you can also add in with serialization and without serialization on all of these. And then cache is basically same as persist, but with the mode as in memory only. So that's the only difference. And if you don't want, you can just do unpersist. That would clear off the stored in memory stored data frame results. It will clear off. And if you want again, or if the data frame is accessed further below down with any action, so it will go back and recalculate that based on the DAG that is built on the data frame. So basically it'll read from the source and then apply all your transformations that you have put in to recalculate the data frame. Right?
Arun, who is our friend Chandra is doing? He is a little bit calm.
Yeah, yesterday also he was probably
Hey, Chandra, how are you?
I couldn't speak yesterday as well.
You're on mute.
It's me or someone else.
Yeah, you are Chandra. Only Chandra is
There's
here.
only one
I did not
Chandra
ask any
here.
question today.
Yeah, see, for you, silence doesn't suit you, Chandra. Eh,
Right. No, I am doing something else. That's why I don't want to do interrupt.
No problem, no problem. Okay. You're just pulling your legs. Okay.
Yeah,
Right.
thank you.
Yeah, sure. Okay. So we also touched upon some join strategies as well yesterday, right? So we talked about broadcast join, we talked about hash join, the shuffle hash join, and then we talked about sort merge join. We just kind of touched upon it. We will dig deeper or look at some examples today on how the strategies are implemented in Spark. But before that, we wanted to just review our Spark transformations using SQL. So how we use Spark SQL to kind of do the same transformations that we have been doing on our data frames using PySpark. So basically, it's the same. So whatever transformations you do using PySpark on the data frame, under the hood, it would still execute the Spark SQL. So the engine would still execute the Spark SQL on the objects, on the data, basically. So it's just the syntax that's different and how you access. So based on, there is no hard and fast rule or recommended thing that you should do PySpark syntax, or you should do the SQL syntax, right? So whichever is comfortable, you can go ahead and do that. So with that, let me share my screen. So I encourage all of you, just like we did yesterday, to chime in, participate in the discussion, and we go through the syntax of how to use the Spark SQL transformations. And as we go through, we can just relate what we are doing with the PySpark to SQL, what it translates into SQL, right? Just give me 1 minute. Yeah, it's the same performance as Spark SQL or PySpark. We have to, yeah, basically that's what we said. So the PySpark also you write. So under the hood, it is Spark SQL that is executed. It's converted to SQL and executed on the data sets. So there's another concept that the machine wanted to touch upon here in the message. So the repartition that we did versus was called coalesce. So it's a small concept, basically like cache and persist, right? So persist, you have different modes, and cache is just like persist with memory only. That's the difference. So similarly, repartition, you can repartition to any of the number of partitions from the existing one. Coalesce is only to reduce the number of partitions. So we will touch upon later. So repartition and coalesce, how they are implementing based on the distribution and optimization. So I don't want to confuse more right now, but we will touch upon it. Just remember that the repartition, you can increase or decrease the partition. Coalesce is only to reduce the number of partitions. And there's a small difference on how the shuffling is implemented when you use these two. We'll talk about it later. And so when we do the Spark SQL, so based on your comfort, based on customers, what customers use, they can choose to write PySpark, or they can choose to write SQL, or they can choose to write a combination of both. And you can also take the objects and use interchangeably. You can refer to the objects created using SQL in PySpark. You can use the objects created in PySpark in the SQL. But then you have to have a handoff between these two. That we will see how we are going to do that. Okay. So let me share my screen here. Okay. You guys can see my screen?
Yes.
Okay, nice.
Yes, sir. That's it.
Okay. Nice. So in this, I'm not actually reading any file. I'm just creating the data, test data here for sample. And I think this is another way of, as I mentioned the other day, so there are different various ways of creating a data frame from various sources. So whatever source you read or you ingest data from, once you create a data frame, it's the same. It does not depend or have different features based on what kind of source you are using. Whether you create the sample data here, or whether you read from a CSV file, you read from a stream, or you read from a table, you read from a catalog, Unity catalog table, whatever it is, or external JDBC table. Only the way how you read and the options you provide while reading will differ. But once the data frame is created, it'll have it's the same for all of the sources or any source that you use. So this is another way of creating a data frame. It's just a list in Python, and these are called tuples. So basically, each tuple is one record here in the list. So once you take this, so this is ID, name, salary, and department. So this is the data, and then you have to have a schema for this. So how does it know? Because in the CSV, when you read, at the top you have the first row normally is a header that will tell you which column it is for the data. And in the tables, you anyway have the columns. So here I'm creating and providing the data and schema separately. So this is the data, and schema I'm giving as a list to read from: ID, name, salary, department. So it will understand these are the column names, and then split this data into these columns when it reads.
Hey, Harun, my friend Nag is new to programming. I want to add one point.
Sure.
Hey, Nag, if you have square bracket, it is an array.
Array, yeah.
Your regular bracket, it is called tuple, just
okay.
you see that?
Sure.
So he took the tuples and put it into an array, So the bracket, when he said tuple, so if you have two, in fact, it's a mathematical word. It's called two tuple, three tuple, four tuple, whatever the number of this one. So that word tuple plays a lot of important role in artificial intelligence also. So tuple has a relation with even vectors. Vector is also like a x1, x2, like coordinates in mathematics. You put x1, x2, x1, y, X1, Y1, Z1, Z1, right? Like that. So
Right.
in 2-dimensional, you'll have 2 coordinates. In 3-dimensional, you'll have 3 coordinates, correct?
Yep.
So human beings only can see 3 dimensions.
Mhm.
Machines or mathematics can see beyond 3 dimensions. So that's why you might have heard in nowadays LLMs, they say 70 billion parameters, they say, right? Have you heard?
Mhm.
Meta,
Yeah.
70 billion parameters, they say.
Right. Yeah.
So they are nothing but 70 billion dimension. Here it's only
Mhm.
it's a 4 dimensions.
Mm.
I'm sharing this word for everyone because you'll be hearing these words going forward very naturally. 70 billion parameters. It means there are 70 billion columns, 70 billion parameters where you can control to change the nature of that model. But anyway, here it's a tuple is a mathematical word. But anyway, it is there in the program also in Python. This is regular bracket, parenthesis. In America, people also say parenthesis is the tuple, but the square bracket is an array. Okay. Does
Okay.
that
Thank
help?
you. Yeah, that helps.
Okay, Arun, thank you.
Yeah, so the other day, I think we can go back and review we did the Python basics. So we learned about tuples and list and dictionary, right? So basically, the square brackets, it's, as I said, array or list. They're interchangeably used in Python. It's called list, which is basically an array of elements. So each element is a tuple, which is here one complete data record. And then we are using Spark dot create data frame. So to create a data frame, you can provide a list of data, and then this is the schema. What are the columns?
Maybe a question to our team, Harun, if you allow me.
Yeah.
Hey, anyone, what is the difference between tuple and set in dictionary? Sorry, in Python. Anyone?
Tuple, you cannot mutate, you cannot change once you define the list, once you add the items. But in the list, you can keep adding that, modify the elements in that.
Not list person. Set, SCT, set and
Tuple. Yeah, set is also same, right? I think you can add the, you cannot modify the elements in that set.
anyone?
Is
Okay.
tuple two items? Set is more than two elements.
Interesting. Set is unique numbers.
Okay.
You cannot have repetition of the same.
Duplicates. It does not allow duplicates.
Whereas tuple, you can have there one LS 2000 in the same this one. There will be another name also. So, but anyway, we'll go. Just want to check with you. Sorry, Harun, go ahead.
Yeah. So this is the data frame. So from here, so I will just move this to new cell. I don't know. Here, I'll go step by step, creating a data frame, and then. So here, the data frame is created. So we are using this spark.create data frame, and then I will just call this employee data frame, and then display this. Any questions here?
So, Harun, can you share that sample data in the chat once?
Yeah, sure. Okay. So see, now we have a structure, we have columns, and we have data in this same data we have got here. So everybody understand this? just sometimes you get a list of data, within the program, you deduct the values, create a list, and then you have to join that list of values with some data, with a incoming data frame or read the data frame, master data or setup data that you will have in list. So like this, you can create a data frame to join with the other tables. Okay.
Harun, what is
Yeah.
the difference between a data frame and an RDD? Like in yesterday's class, I think you used RDD with data frames, right? Like,
Oh,
or
this RDD with data frame. No, basically, see, RDD is the underlying core object which it started. So RDD stands for Resilient Distributed Data Set. Okay. So what it means is that resilient means the one we just discussed. When we cache some data frame object and we did unpersist, it's gone from memory, but even when you again access that object, it will rebuild that object based on the source, and then apply all the transformations and get you back the same data frame state. So it is resilient and it is immutable. So you cannot change the existing data frame in place. You can always do transformations, which will give you a new data frame. Okay. And then distributed. This is what the core, right, that we are talking about. The RDD or the data frame is distributed. So RDD was the original nomenclature or the name when Apache Spark started for the distributed data set. So there were a lot of transformations, operations, the methods or functions that were implemented using RDD. But after that, slowly it has, after the evolution, RDD didn't have a structure in the sense, it didn't have a schema.
okay.
So it's just like this. So you had to again give it a schema. So when you add the schema to the data, structured data with schema together, it became a data frame, which is a representation of a tabular format. So you have data plus schema, it has become a data frame. So basically, the underlying object under the data frame is an RDD. So it's not different, but now recently you can just talk about or think about and work with data frame. You don't need to go into the lower level of RDD
Okay.
except a couple of times when we said like we used to do data frame dot RDD dot partitions, but I think now everything is available at data frame level. You don't need to go in deeper in and at the RDD level.
Okay, got it. So data frame
Yeah.
is the only way you can read data from a table, and it can also be used to read data from files.
Yeah, everything, it's same. So whenever you read data frame, the underlying object that Spark works with is called RDD. So initially, the what you call the APIs are all built on the RDD object. But now everything is moved on to the data frame object, and RDD is hidden underline. So you don't
Okay,
have to
good point,
work
Arun.
RDD level. Yeah, sure.
If you allow me, I'll share a couple of, I think, right direction.
Yeah.
Purnima, great question. Everyone, please understand what a Purnima question is. Harun has explained it very neatly, but just I want to add a few more points. So everyone, please understand, originally when Spark was created, there is no concept of what you call data frame. So there are only three words. One is anything you deal with files in program, as Harun said, RDDs, like resilient distributed data set. It is nothing but a distributed array programmatically. Then you want to do some query sets, etc. Then they will try to create a structure to that. So they take a RDD, then take the schema. Even you see there, Harun, what he's created, employee DF. How he got employee DF? He took the data. The data is data, Purnima, is data in the program. Is that a data frame?
Yes.
No, go and see. Your data is not a data frame. Your data is an array of rows.
Got it.
You see, when he declared data, a Python array of data, array of rows.
But in real world, you won't declare data like this, right? You would either read from a file or a table or something like that.
Correct,
Like,
you read. But what if you read a CSV file without header?
okay.
So then what happens? It might put some junk schema. Then you will apply schema, right?
Right. Got it.
So that's why what he has shown, you see, he took the data, which is nothing but an array. It is a list. It's a list class. Then next step in employee data frame, he used the word create data frame, data, comma. What is the other one he put? That is nothing but schema, correct?
Yep.
So it means you get your data frame if you have data plus schema, correct?
Right.
So that data which you got is an array. Interestingly, in Spark world, since it is a distributed computing, it's a distributed array. It's an array, but it's a distributed array, Purnima. Because Spark make an array as a distributed, unlike other programs. So your RDD is nothing but a distributed array. So you have RDDs, you can have transformations, you have actions. That was the original Spark is created. To create a data frame, you have these multiple steps. You create an RDD, then apply schema, then you get a data frame.
Got it. So you need a data and the schema to create a data frame.
Correct. But now with single read, you can do a lot of things as a data frame. In fact, in going forward in Databricks, they are going to remove the RDDs, actually, RDD APIs. As Harun said, RDDs are low-level APIs. It means programmatically, you need to do group by, sort, all those things you have to do from the file level in a programming level. Whereas if you see SQL, you say select this, join this, etc. Everyone knows, right? It's so powerful. Under the hood, it writes some C program or C++ program or Java program. So it does low-level programming, right? Under the hood. Correct, Purnima? Correct? When you say a group by select, it is almost like English, correct? And under the hood, it is doing a lot of low-level programming, isn't it? Anyone? Maybe who is it? Kishore is a IT veteran. He's even guru to Harun and me. You know, I'm guru to Harun, but Kishore is guru to me. Kishore,
Yes, Srini.
tell me what happens when you do SQL. How computer knows what you should do?
How computer knows. Okay. So it's more about like you are like sending the command. Okay. So and you are like fetch the relevant data as well as from the for the given schema. Actually, Srini.
Okay, let's put I don't want to derail the discussion, guys. You see, everything you see, Purim, are you there in the discussion? You see,
I'm following that everything is an object and we are calling all these objects I'm creating a data frame, and those objects are RDD, like, you know.
Correct, but the whole computer is abstraction, right? Now, suppose you tell to ChatGPT, give me this code, something, or run this code. Assume tomorrow some code is also running in the ChatGPT, suppose. So what it is doing? Suppose you give English. Suppose computer is understanding. What does it mean? So English is an abstraction. That English is converted to next level of programming. That will be converted to next low level programming. Next, it goes to machine language, correct? Ultimately.
Right. Yeah.
This is what it is, right? See, your machine is bytes 0 and 1s. Then close to metal, they will say. Close to machine is C, C++. Then little bit of abstraction is Java, because it has a Java virtual machines, or even Python interpreted. After that, a SQL. So then beyond SQL is English, correct? So if you say a machine tomorrow, do this, machine is doing it. It means the machine is converted to low-level language. Anyway, without confusing everyone, Chandra, Kishore, Prasanna, now you understood? So it started with RDD, as Harun said. RDD is nothing but distributed an array. That RDD used to have transformations and actions. But RDD is converting RDDs into data frames, rather structured. Oh, you need to convert to first data, then you need to apply schema, all these things. There are multiple steps. So to make it simple, they came up with the concept of data frame. In fact, Purnima, these data frame concepts were borrowed from pandas, some Python data processing world. So your data frame is nothing but a data with the schema together, so that you can people can comfortably query just like you are querying the tables, but in the programming. So long story short, Harun is right that RDDs are original APIs, low-level APIs. It has if you add structure to it, you will have data frame. That is where really you do your analytics. But now everything is going to be a data frame. But if you know a little bit of RDDs, etc., you know the low level, you appreciate this technology. Does it answer your question?
So
Yeah.
Srini, in a sense, okay, we are moving more towards functional programming, where we are like doing the less coding and more with limited coding. Okay, we are achieving a lot actually, rather than like writing hundreds of rows of code. Yeah.
Correct. You hit the bullseye. Right. Does it make sense, Purnima?
It makes sense, Srini. Thank you.
Okay. Super. Thank you. Sorry, guys. I don't want to derail your discussions. But
yeah, sure.
Yeah.
So that's how we have created the data frame from the sample data here. Now we also have the similar data structure for the department, but we'll come to it. Okay. So for now, once we have this employee data frame, what we can do with this, right? So one, we can create a view on top of this data frame. Okay, it's a create or replace temp view. But before that, before going there, so let's say employee df2 equal to, so remember we did the transformations on the data frame. So I want to say just select or with column or select expression, right? So if I want to say select employee df dot select, I'm only giving name, and I'll just say employee df2 dot display or display employee df2, both are same. So this is a transformation I have written on employee df, which is created here. And this data frame has only one column called name. So that's what I have only selected. So that is stored in employee df2. And we also have seen that employee df still stays the same, right? There is no change in the employee data frame, the original data frame. Everything you do transformations on data frame will give you a new data frame, which is employee df2. It is up to us. If we don't want this anymore, the original one, most of the times you just reassign to the same variable. So it looks like you are modifying the same object, but however, every time it's creating a new copy of the new object and destroying the old one. But I don't want to confuse more on that. So let's see. Employee df2 is just a transformation on employee data frame. What kind of transformation? We are just selecting name. Now, in the SQL world, what does this look like? So let's ask Akshata. You're familiar with SQL?
Yeah.
No. Okay. So what does this transform into or transcribe into in a SQL world?
I didn't get the question. Oh.
So how do you visualize this in SQL?
Okay, so I am from employee DF data frame. I'm just selecting name column and then putting it into a new data frame, which is employee DF2.
Yeah, great. Yeah, close enough. Anyone else? Prasanna?
Yeah,
Lakshmi?
it's actually you just do select name
Creating
from
a new data frame df2 and getting the data from df1 and separating only the name column and displaying it.
Right. Yeah, that's also correct. Yes. Close.
Select name from
Lakshmi,
employee
Prasanna,
DF.
you're saying something?
You're asking like what does the select represent or like
Yes,
how the
yes.
data frame?
Yeah.
Yeah, it just like select name from the employee table.
Right. So it's just like we are doing select name from employee data frame,
Oh,
right?
okay.
This is what it
Yeah.
is we are doing. If we want to visualize in a SQL world, it's like we are selecting name from this table. So this is actually not a table yet. It's a data frame, right? But it's still the same visual representation. So it looks like a table, data frame, and it has columns. So, but we cannot directly select from data frame. So to do that, what we do is you create a temporary view on this data frame. So it's like you are putting a database lens or a table lens on the data frame, or you're referring it with a new name called employees, which is a temporary view. So why is it a temporary view? There are again a couple of options you can do. There is a create or replace temp view, or there is a create or replace global view. So that's just basically the scope, like local and global, that we can talk about later. But the scope of this temp view is within this notebook. So just remember that. So I'm going to create a temp view called employees on the data frame. So which data frame? I have employee data frame, right? So employee underscore DF. This is my data frame. Remember?
Mm-hmm.
So I'm going to call this employee underscore data frame as employees in the SQL world or in the database world as a table. Now this will be my database table. I can write any SQL on this table, and it will be pointing to the data that was created using employee data frame. Got it? So now when we want to do the SQL, again, there are various couple of options. One, you can do it within the Python itself using PySpark. You can just do your SQL, or you can also directly use Spark SQL cell. So how you do it is, see here. This is what we are doing. So I'm selecting columns from data frame, which is same like what we did here. Okay. Now let me also get this and put here. Okay. So employee data frame dot select name, that is column name. So this is doing a transformation on this data frame in a PySpark node. Using Spark SQL, what I'll do is spark.sql, and I will give my entire SQL statement in the string. Just like, in any programming, you even in Java or Python, wherever you want to execute, you just first generate the SQL statement as a string and then pass that string to execute, right, to database. The same thing you can do, select ID comma name from employees and execute a Spark SQL. It will again give you back a data frame. Okay, so this data frame, we have all of this here. Let me take this out. Okay, let's just look at this part. So this is the first data frame that we got from here, employee df.select name, which is your emp df2. And this is the second data frame I got from here, spark.sql. I'm using the table name directly here. See, it's called employees. I'm just writing, referring to it as if it is a table. Select star from employees or select ID name from employees. So whatever SQL I want, I can put it on this table. So that's again a new data frame. Now I can just do any transformations again on this data frame as well. So I can just do again df dot select name. Okay. So this is a new data frame now. I'm selecting from this selected columns data frame, which is I'm selecting from this employees view. Now we can do display on this. See, now we got the same data frame again from this. Okay, you guys are clear how we are interchangeably using the data frame and the table as a table just by adding this one line, like create or replace a temporary view on this data frame with this name. Yes, got it? Any questions on this? Nag, Hari, Amrita?
Yeah, this looks easy.
Okay, this looks easy. Okay, so we are getting into our familiar SQL world. Okay.
Yeah, SQL. Yeah,
Yeah.
that's right.
So yeah, this is the employees. Okay. Now we can write our SQLs here. So how we progress with that? Let's see. So I have created another department data to do our joins, SQL joins. And then we are doing department DF here. I'm creating this and I'm calling this again, registering this data frame as a view called departments. Okay, so now I have my employee table. Now I have my departments table. So next I can start, writing SQL. So here, can you see this data, how I've created the department data here and provided the schema, department code, department name, right? And then created the data frame using this data and this schema, right? So this is the view I have created on this data frame, department DF called departments. Now, so we are looking at Spark way or data frame way of doing Spark SQL here, ID name. So this we have already seen from this. Now, how we're doing transformations. So this is selected columns. This is the data frame. I'm selecting from employees view. And then this is another transformation, the filter basically. I'm writing where class on this. So when we do the original right from employees, say employees DF, so filters, filter rows, let's say this, and I have my employee DF dot filter in the filter. We mentioned, right? How do we write our filters? Anybody can give me syntax for using the data frame? So I can just refer dot salary greater than 1800. Let's see if I can do this, or we look at the syntax. Remove this. Okay. So look at these two data frames. Now, first thing, one second. Yeah, sorry, I think I lost the share screen. One second. So this is the selected columns DF dot show. Let me convert this to display here. This is
Harun, one question. So what is the difference between display and df dot display and df dot show?
It's the same thing. It's how it it's just the format it shows, right? It's more tabular format, and instead of the string and all that, it shows like a table, column name and the values just in a tabular format. Both are same. It's just how you see it on the screen. Okay, there's no difference. See, it's just the visualization how you see. Here you have additional operations that you can do. You can download a dashboard. You can sort here based on the this IDs, see 541. It's just more interactive. That's it. Okay. So now if you see, I've written spark.sql. I have written a filter, employee ID dot filter greater than 1800. So you got 3 rows here. And the same thing I'm writing in the Spark SQL syntax. Employees where salary greater than 1800. So here also you will see, let me do this as well. Okay, so you got the same result, right? If you see 145 IDs, which is salary is greater than 1800. Basically, this is one way of writing the SQL, Spark SQL, right? And this is one way. So basically, if you see now, can you explain why, how we got these two as same? How it is transformed into this? Shiva, can you talk about this?
Sorry, say it again. Sorry, Harun.
Yeah, can you talk about how this way, this representation, where what we are doing a filter transformation, filter on the employee DF,
Yeah.
the same as the SQL here.
Oh, okay. So, the data frame converted into Spark SQL, right? So it's again the similarly start from the table where the salary, the condition, right?
Right. Yeah, exactly. So basically, employee data frame is what we are doing transformation or filter here. So that employee data frame we are referring as employees table here, since we registered it as a temporary view with the name employees. Remember here. So wherever we do use this employees as a table, it is referring to the employee data frame, underline the same data. Now, the filter employee data frame dot salary greater than 1800 is same as where class. So where salary is greater than 1800 from employees. So basically this entire thing is what is converted into the SQL part here. So your filter gets converted into the SQL. Okay, so you can as well, add more filters or add multiple conditions into the same filter as select expression, and then give more and give more conditions here. Okay, and then say where filter, you can do employee df dot let's say department equal to HR. Okay, now if we run this, what happened?
HR is single quotes or double quote?
Oh no, and this is see it actually gives you the suggestion, syntax error. Perhaps you meant equal to. The comparison, right? So when you are comparing, you're not assigning value. So when you're comparing here, you are doing equal to. So 1 equal to is like assigning value. So now if you see here, you got only 2 values, HR. So you are filtering on salary and filtering on department. So now how does this convert into SQL? Anybody? Subbu?
You
And
okay. And department is equal to HR.
Yeah, exactly. So let's say, and we can write here this equal department equal to HR. So now,
Is it case sensitive, Harun?
so comparison will be right when you are doing a SQL, unless you do, normally your where class is always case sensitive, right?
No, not in SQL.
it's a department data. So
Data. Right? So let's see what happens if we just. So there is no results from this because there is nothing matching this HR. See, this statement is not case sensitive. You can do this column name as capital salary, this capital salary and end as capital, whatever. It will still work. But inside the quotes, it's the data that it is comparing. So it has to exactly match unless you choose ignore case or two lowercase or two uppercase functions you use, right, in SQL. When you are
No,
you want to do a
in
case
SQL,
sensitive match.
in SQL, it's not case sensitive. I'm in SQL, we don't give, like, data is not case sensitive. You can query uppercase, lowercase. I'm not sure. I can go back and check, but
No,
maybe
but
this is case sensitive in here. Okay.
no, wherever the SQLs I have worked, Oracle database or
Yeah,
everything, like within the string, it's a case sensitive. Within the string, whatever you give, it's exactly matches the same.
Yep, it needs to match the data. Yeah.
Yeah, there are some in MySQL and other, but not all.
Yeah, read.
I logged in. I don't know why it's going to you still.
Okay, sorry. Yeah, I think it is case sensitive most of the times because we are comparing the data unless you use the case sensitive, or normally we use the functions like two lowercase or two uppercase kind of a thing. But yeah, that is SQL that we will get to. But here we have seen, right, it's still here it is definitely case sensitive. If you use lowercase HR, you don't get any matching. So you don't get any data. So now you get this one HR here. Okay. So this is the transformation of queries from how you chain this. You can also add here itself. With the proper syntax, you can also add this. You don't need to add multiple filters and chains. Chaining, you can also add here, or there's another way of doing it. Dot select expression. There also you can do in quotes, whatever similar SQL kind of a thing. Okay. Now, so we are doing the aggregations. So remember last time when we did Spark SQL DF dot group by, and then we give department dot aggregation salary. That remember? So let me go back to what we did here. So we did like this group by main category and count, right? And then we also did main category, subcategory, and then we did average of discount price, and then we did rename all of this, right? Remember? So the same thing, we can do it using directly as SQL, our normal group by statements. Not this one. Which one we are doing? Oh. This is the one, right? Where is that? Yeah. So basically, yeah. Now what we are doing average salary based on the department. So we are group by department, and then we are selecting department and average salary. Okay. And here we are joining these two tables, employee and salary on the department code. So we can see this. So it's the same thing. Once you get this, right, just put spark.sql and then write your SQL in the string, in the quotes. That's all. So let's run this average salary df. Okay, from employees table, this is the average salary that you have in the data frame. Now, if we are joining this on the common key, which is the department in both the tables, right? So an employee, we called it department. In the department, what is the column name we had? What did we give the column name in department? This is employee schema. Department schema. Yeah, we gave department name, right? So in employee, it is department. In here, it is department code and department name. So department code is HR, name is full name. So it is the code that we are using. So we join on the department code. So look at this. Okay. So employee and department. So in the data frame, also you do, right? In the data frame joining, you can do just like employee df dot join, and then you do a department df. That is your data frame. So this is the department data frame. Comma. You can give the name on, right? and then you can give employee underscore df dot department equal to, you write your department df dot dept code. So syntax you can check. I'm not sure about it, but it's something similar. You write like this.
COD code. DEP underscore COD code.
Sorry, Subbu?
In the syntax is DEPT underscore code CODE.
Yeah. How it should be? Yes.
There's no on, Harun. Like you give the data frames, department df, comma, employee df.
Okay.
And the df, df1, the employee equal to,
Yeah. So there is another syntax also. You give the quotes on, and then you give in quotes, you just give the field name, something like that. So there are different variations, different options that you can use. But yes, so basically, this is what you are doing, right? So employee df dot. Oh no, sorry, not employee df. We have to assign it to a joined df1. I will just use so that. Okay. So basically you are selecting all the fields here. We are not selected any of that, but you can also do a dot select, then whichever columns you want to select, you can do all of that. So that is what is basically converted here. You are giving from, joining this table and this table, these two tables you are joining, you are giving a joining key here and selecting the columns here. So basically it all comes together and represents the same thing as we do here.
Why did we give 3 double quotes in your joint DF? Is there a reason? Because you were giving only one.
That's just string representation. You can as well.
Okay.
So here, basically in Python, you have to do this string representation, right? So to do all of that, they use 3 double quotes.
Harun, quick question to the team.
Yes.
Everyone, by the way, you guys are doing a lot of this stuff, but why we are doing what we are doing here? Purnima, Prasanna Gattamaneni. Why you are doing all these things? Okay, now you're spending hours and hours. What is our end goal?
We are doing the data transformation and
Correct. Beautiful. So your role is going to be to do ETLs, correct?
Mhm.
As a data engineer, you extract, which is read, you load, which is write, easy. I'm talking about transformation is the one you are doing. So all the transformations are nothing but SQLs. But the only thing is, as Harun said, they're represented as a PySpark syntax, which a lot of people are not comfortable. If you're comfortable, write that way, or otherwise, do this way. But ultimately, you get the result. And this notebook, you can eventually, productionize it. All those things you can learn. But the goal is to do the ETLs, which is nothing but transformations, mainly the core. You can also do this in the streaming, which is in real time. So awesome. I'm glad you know the end goal.
Right.
So that nobody is lost. I really appreciate you guys are to the point.
Exactly. Okay. So this is, so we can go on writing whatever SQLs we want to. So all of this, it's basically the same. You can write any SQLs, just like transformation. salary equal to salary into times 1.10. You're selecting renaming as column increased salary from employees, selecting all the columns plus with column. So this is basically a with column transformation, guys. So you say df dot with column, name is increased salary, and then expression is salary times 1.10. So that is what is the transformation here. Select existing columns and new column increase salary, which is calculated as salary star 1.1 from this employee data frame. So this is your new data frame. So same thing here, it's just order by salary. Basically, it's just an order by class. Right? So, so you can take one of our previous Amazon data set and check what all transformations we have done, and then try doing it, rewriting it using the SQL syntax, Spark.SQL syntax. So another way of doing that is this SQL cell. So you see here %SQL. We have seen earlier that if you go here, you can do a Python, right? You can do markdown, that is just writing text, the comments. And then you can also do Scala R, that is different languages. And you can also do SQL here. So when you do SQL, it will automatically write %SQL, and then you can write your SQLs. So this SQL cell can access the SQL objects, just like once you have registered the views, right? Temp views as employees, temp views as department. So those two objects are available for SQL cell. It can directly access that and give you result. So basically temp view departments and temp view employees. So select star from employees. So you got this. Okay. So here, what you are doing, remember, when you come back, you wrote spark.SQL. The result is, again, you are able to store it in a data frame and use it further if you want to. But here in SQL, there is no PySpark object, right? So how do you take this forward? So if you want to write a SQL ID and name, and I want to use this further, how do I use it? So basically, yeah, go ahead to talk.
You will create a view, right?
Yes. So there are again two ways. I mean, you can create a view on top of this, right? Just like you can say create or replace view employees view as, and then you run this. So next time, if you have a cell, so here, let me set this. Code %SQL, select star from employees view. Okay. So I can run this. So it's not defined yet. So I have to go back, run this. Not allowed to create a permanent view. Okay. So you have to do temp view, something. Temp view, I think. Yes. Let me see the syntax. Yeah. So you have to create a temporary view, and then you get again the same. Employee ID, name as this. So this is the view that we created here. We are referring here, employees view. Okay. So this is one way of adding objects or creating objects for each transformation as temporary views, and then using it in further sequence. Or if you see here, it says SQL cell result stored as PySpark data frame _ SQLDF. See here. So if I just I'll leave this cell as is. Okay. I will go here, create a new cell, and I will remove this. I'm not creating a temp view. Okay. I'm just doing ID name from employees. Okay. So here it again says SQL cell results stored as a PySpark data frame. It actually is giving you a data frame already. Internally, it is giving you an object that is pointing to result of this SQL again. So what you have to do is you have to assign this underscore SQL df to a data frame. And then you can start using the data frame again in your PySpark node cells. So this is how like you move objects between PySpark and SQL environments or cells here. See? Okay. So from PySpark to SQL, what do you do? To take the object. Hari? Anag? So from PySpark data frame, if I want to use that as a table in SQL, what I need to do?
Register the data frame as a table.
Exactly. Right. Awesome. So you register the data frame object as a temporary view. Create or replace temp view. Table is always there. So once you write to table catalog, you can access it anywhere in data frame or in SQL or in another notebook or whatever. That is different. So that is like persistent. So within the same notebook, if I want to, move access objects in between SQL and the PySpark cells. So from PySpark, you have a data frame. Yes, you register it as create or replace temp view. You give the table name or view name, whatever, and then you access that as a view in the SQL objects. Now from the SQL, I write a SQL, I get results, but in further processing, I want to use it in a PySpark data frame. So I want to do a distributed processing on that, a join you can do SQL also. You want to do any more transformations or anything you want to do with PySpark, you want to write logic on that data frame, do some processing loops or whatever, then you can take that underscore SQL df object and assign to your any new variable and use it as a data frame. So you can also refer this, but what happens is every time you execute, this variable gets overwritten with the new results. Just like in your SQL ID, every time you run a SQL, you get new results there, right? So you store it in a different variable so that it's already there in this data frame. So next time you run again SQL df, you get different results, whatever SQL you have executed. Okay, are you guys clear?
Yeah.
I have a question in all these things.
Hmm.
Like PySpark and SQL Spark.
Hmm.
So where to use what is the best way to use code means PySpark or SQL Spark?
So there is no best way. Both are same actually. Whichever is comfortable to you. Both will underlying the processing is same. The execution is same. The performance, everything is same. It's just the syntax. Underlying bit code it gets converted into will be same. SQL will be same. It's just what you are comfortable with. If you don't know SQL, you only know Python, you can use PySpark syntax. If you know SQL is more comfortable, just add one line register as temp view and then do SQL, spark.sql. Both are same. Basically, it's not like whichever is recommended or whichever is good. It depends on that particular client or use case, what, how they define, how they want to do it. They prefer more PySpark or they prefer more SQL kind of thing.
So Harun means we can define the like if we want to get the results based on some dynamic parameters like date or year or any. We can use PySpark data frame using the widgets where we can define change based on the like on the days or years, right?
I didn't get your question.
So if I want, let's say I want to get a results using PySpark data frame, and I want to that parameter be dynamically passed in the somewhere, which I can change it. Then I can use the PySpark data frame, and then the SQL.
Yeah. So everything, I mean, so you can use your configuration files. You can get data from your master table, read it, and then you can use that in the data frame. Yes. Okay. So basically, so that is how you kind of represent the same transformation using data frame transformation syntax, PySpark, or using spark.sql syntax, or just using %SQL, Spark SQL cell, writing pure place SQL. So the 3 different types. So take any of the existing notebooks that we had, right? And try to convert those whatever transformations we have done, convert it into SQL transformations. Okay. Any other questions before we move on to the next topic? Just I'll take 2 minutes.
I think we discussed initially, I think the optimization or the performance shouldn't differ, right? Whether you're using data frame or Spark SQL, it should be the same, the underlying.
Yes.
Okay.
Yeah, it's basically the same. Even if you have created a temporary view, it's still pointing to the data frame, underlying data frame only.
Okay. Yeah.
Which is already distributed in the memory on nodes. Yeah. It's just, what you want, what you are comfortable referring to and working with. That's all.
Yeah, with writing. Yeah.
Yeah, writing. So take any of these, any of this existing notebooks, and see, we have this column names, rename. So how you write SQL to this? How can you write SQL to regex, replace this characters, casting into this and renaming it. So try doing this, all of this in the SQL filter, where clauses for these, combining all into one where class and do that. Okay. I don't know why this so start minute. So let me start. Okay. Just give me 2 minutes. Srini, you can rock. We'll start with the joins. I will be back in 2 minutes. Okay, welcome back, guys. So are you all good with the Spark SQL? Anybody has any questions? You can go ahead and get started working on any of those assignments, any of that sheet, and then try doing SQL on that. You guys can hear me?
Yes, sir. Yeah, we can try.
Yeah.
Okay. Okay, fine. So the another topic that we touched upon yesterday, you remember the joint strategies that we were talking about. So we talked about three Spark join strategies that Spark uses when you do a join between the data frames. Can anybody recollect?
Yes, yeah.
Yeah.
Broadcast has joined
Mhm.
and sort merge.
Mhm.
Shuffle hash.
Yeah, shuffle hash join, right. So basically, most of the times Spark will decide based on the size of the data frames. It either it chooses the broadcast join or it chooses the sort merge join. So the default join is the sort merge join for Apache Spark. However, as I said, like we can provide hints just like we do in SQL. We can provide hints if we wanted to use any other joins, better joins that we find, or sometimes if we are sure that broadcast join will help the performance better than the other joins. Okay, so we looked at one second. So we talked about what is the broadcast hash join, right? So yesterday briefly, if one of the two data frames is smaller, which can completely fit into a worker node, that without being distributed, right? So that it can ship or make copies and send it to all the worker nodes. See, your large data frame, as we discussed, distributed data frame, it sits on multiple nodes. Okay, so here representation, you see, if it has like large data frame with 4 partitions. So partition 0 is on this node, partition 1 is on this node, partition 2 is on this third node, and partition 4 is on another node. So on 4 different nodes, okay, we have 4 partitions. Now, let's say the other data frame is also on these machines. So previous classes we have seen, if we want to join, all the keys should coexist on one machine. So it has to shuffle the data based on the join keys so that all data is on one machine, and then it will do the join. So shuffling involves network, moving the data from into different nodes, IO operations, performance, and all of that. So if we have a small data set, it can just create and send the entire copy of that to each node. Okay. Now the entire data of this is here. So it can join with this data set. And it can join this data set. This can join this data set. This can join this data set. So now entirely the entire data frame is joined with this, right? Without even doing any of the shuffling. So that is called the broadcast join. So first and foremost requirement for this is to have a smaller data frame that can be created copies of and shipped to each nodes. Okay, sometimes that can also be costly. You can define what is the size of the data frame that you will ask Spark to consider it as small. Small is again relative, right? So 1 MB is small, or 10 MB is small, or 2 GB is small. So what is the size that it can fit in each of the nodes? So if you say each of your worker node is having 20 or 30 GB memory, then 2 GB of the table can also be small table. You can consider and ship it. Or if your entire memory is only 8 GB, and then you have bigger data frames that you're sitting on that. So only 10 MB can, fit in each of those. So basically it's like seeing what size you consider as a smaller data frame. So default size, I think, is 10 MB. You can check on that, but you can decide. So you can also mention threshold. Broadcast hash join threshold is like, say, 2 GB kind of a thing, right? So, and then we have shuffle hash join. It's basically the same thing. We have two data frames we have been talking about. So the keys are not coexist. So it has to shuffle around to make sure the data with the same keys are on the same machine for both the data sets, for the data frames. So it does worker 0, 1, 2. So there are a lot of arrows crisscross. Data is shuffling across all worker nodes. So once the data is shuffled, then it does a hash join. The sort merge join is also similar to that shuffle join. Here also data gets shuffled, but before shuffling, it just does a sort on that. So it sort by keys so that the merge algorithm, so merge or join, will be easier on this. And this is the sort merge join is the recommended strategy by Spark to do the joins. So let's see how, when we do execute this, how does it execute in terms of the strategy? So I have different data sets here. So I've taken this movies data set. We have already used this earlier for different transformations. So I'm using the same. This is a big data set, movies.csv. It's like half GB of data. Not this 9,000. Yeah, sorry, movies and ratings. Okay, so movies is only 10,000 rows. Ratings has like 100K rows in this. Okay, so the ratings is the big table and movies is small table, because each movie can have multiple ratings provided by multiple users. So the ratings is a bigger database, a bigger table. Movies is a small table. So you're joining just like employee and department. So department would be a smaller table, employees would be a bigger table. Or you can say order and line items, or you can say products and orders. So product will be 1 and order can be 100 or 1000 for one product. So basically, if you have 1000 products, orders can be in millions. So when you're joining these two, you can consider the size of products table as the smaller and do a broadcast hash join. So you're just broadcasting the smaller table, entire table to different, shipping the entire table to all the nodes, copy of it. Okay. So this is the movies data frame. We run this, and this is the ratings. Okay. Now the join. So what we are doing here, ratings dot join, movies is the smaller. So we always keep the smaller table on the right side, and we are joining on movie ID, and the join type is inner. Okay. So yeah, we were seeing, so this is another syntax that I was talking about. You can have data frame IDs on your joining and what type of join you are doing, inner join. And then I'm asking explain. So remember, in SQL also you have this explain plan. So when you do a explain and display the join data frame, so it will automatically check that this is a broadcast hash join. Okay. And then it will try to ship this movies data frame to all the nodes. So this is the physical plan. If you are aware of like in the SQL, so you do a explain plan and go through the cost and when you are tuning the SQL, you use that explain plan and see how much is the cost. Is there a full table scan happening or the indexes being used and all of that you do, right? So all of that is done by the Spark engine. Okay. Adaptive query engine, which we talked about. So it says here final plan is false. Okay, this is not the final plan. It's just the initial plan based on what it does. Why it does is when it is actually executing, it can still tune it based on the intermediate results, like we talked about. If suddenly large table becomes small, it can change the join strategy based on our transformations. If we filter out most of the values and it becomes a small table, then it can change the strategies in the execution. So final execution. Okay. So there is a complete sequence of how an execution happens in the Spark. So that also we will discuss. That's another advanced topic. What is a physical plan? What is a final plan? What is AQE? How many layers are there before it does actual execution? So all of that we will discuss later once you are comfortable with these basics. And this also, as you were mentioning, you don't have to worry too much about this. You are not every day you don't go and see this plan and do that. Most of it is automatically taken care of by the Spark, but it's just good to know. You should at least go and see what is happening. If some job is running, taking a long time to run, then this is also one of the tools that you see to optimize the performance. Is there something issue with the join? If it is by default using sort merge join, whatever, can we try doing it to broadcast hash join? So you can actually force the Spark engine to use broadcast. If you feel that yes, I can use broadcast, I have memory in the nodes, this will be faster if you can do that. So how you do is not like normal in SQL, you do hints, right? The same way you can also do hints here. So if you go this here, broadcast, so there are join hints. So when you're joining tables, you can send these hints: broadcast, merge, shuffle hash, shuffle replicate, and nested loop kind of the joins. So we are just touching upon the first three. Broadcast, it has automatically taken right now. But if you want a merge, sort merge join, you can do a hint merge. If you want a shuffle hash join, you can do a hint shuffle hash. So this is like SQL, right? So when you're doing SQL, this is how you can provide SQL hints to the tables that you are joining. Okay. Shuffle, merge, and all of that. So here, it has already considered broadcast hash join, so we don't need to do anything. So that's good. So I have another file called movies here, data set that I have taken and I've cached it. And I have created a copy of that. Basically, they are same data sets. I wanted two same big data sets. So I kind of copied the same data set and created another one, movies copy. So it'll have the same data almost, and same columns, same schema as well to join. So, so this is like, as I said, there are a lot of tables, more than 100K tables, I guess, on this. Let me see, count. Let it count here. So guys, are you following? It's your guys are very silent. Are you following what is a broadcast join?
Yeah,
Yes,
yeah,
sir.
Harun. Yes, sir.
Okay.
Yeah.
Yeah. So we have 722K rows in this. So basically same in this as well. So two large data sets. Okay. So now see, sort merge join, as we said, is the default. So what we can do, we can forcibly set that to false. Spark configuration set, prefer sort merge join to false. Okay. And then I go join df, join movies df, movies copy, both are big data sets. And then I give the hint to use shuffle hash. Join on ID, type is inner, join. Okay, and then you can do explain plan. Okay, see here, does the shuffle hash join. So this is in-memory table scan because we have cached, remember? So we have used cache here. Yeah, we have used cache for both the objects. So it's using in-memory table scan here. In the in-memory table scan for the second as well. But more you have to look at is shuffle hash join that it is using. Let's try to see if we don't do this, what happens. Again, I'm just doing this so that you should be aware of the concepts. Okay, it's not that every day you will be asked to, try this, change this, get this, but it's good to know. If there is an issue, what are the levers that you have to tune or to fix, troubleshoot the issues. So if I don't use hint, let's see what happens. What does it do? See here, it changed to sort merge join. Guys, do you observe this?
Yeah.
Yeah. So if we don't give any hint, if we don't force it, by default, it will take sort merge join because it knows that it is, faster. But if you want to force it to do our way, shuffle hash join, so we can do that. I don't think of any scenarios where you would force this, but sometimes if your data set is already sorted, you don't need to sort it again. You just need to do a shuffle and join, then you can use it. So now it moved to shuffle hash join. Basically the same I did here. Sort merge join true. Don't have to explicitly set this. It is already set. But if you just join hint, you can do merge. Even if we don't do, we have seen it automatically takes sort, merge, join. Here, sort, merge, join. Okay, so these are the just the concepts to remember, good to know. Try to run on data sets, try to see changing the strategy if it works. They'll give you more confidence to when you talk about the internals of Spark. You also know how the internally the joins strategies are implemented within Spark. Okay, so that is all we have here at time for this class. So 2 things. How do you feel the class today? And if you have any questions before we wrap up.
So Harun, most of the times you let Spark choose, right, the type of join. So unless you know the data sets that you're working with very, very well from business perspective, and you know the Spark architecture, how your node cluster is set up, then you want to decide. Otherwise, you'll just let the Spark decide on its own.
Yes, yeah. Most of the time, the first pass or normally Spark would take care of it, because it has, as I said, we'll talk about adaptive query engine that, tunes the queries, the merge, join queries, how it wants to implement. But on some cases, exceptional cases where it can't figure out, that you have more knowledge, you want to try something else where it is taking, you feel that it is taking long time, or you feel that some partitions are taking more time, the data is queued, some node has more data than the other nodes, and then you feel that other table is actually smaller, you can do a broadcast join. So those scenarios, you kind of try to intervene and push, override something. Yes.
Shiva, this is like some additional tools, levers, how use. Like you have a car, it's running good, but still you need to know, where are some tools. If you get, your tire got punctured, where is that Jackie, other things, or even at least you need to know where is your spare tire,
Sure.
Some people don't know where is the spare tire, because different cars will have different places, So, it's not, I want to make sure you won't get confused that, oh my God, every day I'll be doing this like that. So you need to understand, you will be knowing what goes on. If you reach a situation where the job demands a fine-tuning things, making it more efficient, all those things. So next is all these things, it takes some time to get comfortable. So what you need to see is, hey, am I getting a good hang of this? Do you feel a little bit, is it opening more insights for you? Do I appreciate, oh, this is not a general computing, this is a distributed computing. Distributed computing world is a little bit different. That's why this career is more valuable, and enterprises able to leverage do you see the advantage of distributed computing to speed up a job which can run 4 hours can be run in 30 minutes, because you run things in parallel, in cluster. You have billions of rows or trillions of rows even. Can your job run without fail? Can it handle at least 1 hour or 2 hours, even if it run 5 hours? Can it complete? Can it does the job? So those things. So there are no limitation for scalability here. You can handle terabytes, petabytes, anything. Of course, in single job, you will not have petabytes. But your data lake ultimately grows up 100 terabytes, 1,000 terabytes, petabytes, 5 petabytes, 50 petabytes. something like that. So this is amazing, amazing. How does that sound, Sahil? I know you have a lot of knowledge of this, but still you are seeing detail step by step. How does this sound like for you?
Yeah, Srini, definitely. It's like a more deeper information about what Harun is displaying. Definitely.
Super. Purnima, how do you feel? Is it opening up the lot of thought process? Of course, I know you need a lot of practice, but how it's opening up insights for you?
Yeah, it's great actually. I can correlate so much of these concepts to what we do in SQL, forcing the query hints and controlling the optimization wherever it's needed.
That's beautiful. So these are the same concepts. Only thing is you are doing in a large scale, in distributed way. So your Oracle or OLAP, other even Teradata, the so-called Teradata, great Teradata will fail to run big loads. Prasanna, Lakshmi Prasanna, and Prasanna Gattamnani. How do you feel? Is it opening up thought process? If you practice, do you feel a little bit comfortable? Yeah, you might feel comfortable. How does it sound?
Yeah, I mean, yeah, if we start practicing and practicing more, yeah, definitely it will be.
Yeah, I don't say you'll have to work 10, 20 hours per week. Honestly, if you can spend 4 or 5 hours, really you feel comfortable. That's how it is. Pawan, I think your friend is doing very good job. Harun is helping you and the team.
Yeah, definitely, Srini. The examples are simple and very clear. Yeah.
Super. Pawan is Harun's friend, I think colleagues or something. Sometime back they had some discussions. Awesome. Akshata from Northwest Seattle. How do you feel?
Yeah, I feel really good. I mean, today's session was very interesting. Yeah, I'm looking forward to more sessions like
Super.
this.
Hari Subbu from Costco. Hari, can you
Yeah,
do I know
yeah.
Hari? Hari, somehow we didn't talk much.
I'm sorry, I had a mic issue, something like that. I even tried to answer like when Harun was pointing out my name as well, but I couldn't turn up. Sorry. Yeah, it was a really good sessions where it is giving kind of the more informative informations along with the real-time examples. So, like since I'm coming from the different background, I would say that from non-IT, I mean, I was just trying to correlate like how does the SQL works into the different platform when we comparing it to the Databricks, how this is going to be working out. So I was just trying to correlate those things, and yeah, I
Super.
have
You are a
the
business
little.
analyst, right?
Yeah, that's
Okay, so
correct.
make sure, hey guys, make sure your infrastructure is good, your mic is good, all those things. I know here and there hiccups happen, but
Yeah,
it generally you carry these things into work meetings also. You will be lost. See, make
agreed.
sure in this class you are heard and your name is called or you speak out. People should know who you are. If you
Agreed.
sit little bit, go back at work also, you'll go back. Now AI is going to cut the jobs, not going to take everyone's job, but you should be more human. Human beings talk. We are social being, right? Our innately everyone, it helps everyone is recognized. Who doesn't like recognition? Chandra, tell me. Who doesn't like it?
Everyone need attention and appreciation so that
Exactly. Everyone needs.
it feels aliveness and more joyfulness.
Exactly. But it is your job at least to say hi. At least you are there, right? Even when you attend some meetings from other customer, etc. I know it's okay. You can be out of Zoom video, but at least make sure you talk. They know who you are. Actually, I know Hari, but somehow I forgot the last 2, 3 weeks. I met him. He is cousin to Nag, and
Yeah,
now I tell Hari, you are from business analyst. Now I recall, see, when we started speaking, because I recognized your voice, but by looking at your name, I did not, because you're not seen. So make sure, guys, that